going to revisit domain and range of quadratics. So what we did before was basically a piece of a quadratic, and we didn't follow the quadratic all the way through with the functions. They had some endpoints there. So now we're going to have that, unrestriction of just the two endpoints. So let's first go back and kind of refresh our mind on what domain is. So domain is the set of all x values. And then range is the set of all y values. And then remember from the vertex is that top or maximum point or the bottom or minimum point. So it's either the maximum point or the minimum point. Now, if you'll remember from that vertex, we have that axis of symmetry. So it's going to start reflecting itself back over that axis of symmetry. So you'll see some, and when we look at this table here in just a little bit, you'll kind of start to see some familiarities about that. So that vertex is going to be that maximum or minimum point, and then it's also going to be the point of our axis of symmetry. So we're going to find what I call the mirror line. So that's kind of sort of what I call this axis of symmetry. And then we have our transformations. So remember with our transformations, you just want to keep this in mind as you look at these, because you want to kind of sort of keep in mind or try to come up with that function as you start seeing these shift right, left, up, or down. So remember if we have y equals negative plus or minus a times x plus or minus h squared plus or minus k. So that's all our transformations. Remember, a is either makes it open up or down, wider or narrower. H shifts right or left, and then K shifts it up or down. So just a quick refresher on all of that information before we get started here looking at our domain and range. So anytime you have the full function of a quadratic, the domain is going to be all real numbers. So if you'll look at my first example here, it looks like technically that it stops here and here. But it really doesn't stop. It's going to continue going on forever and ever. It's going to keep getting wider and wider. Now, it's going to have to go up really high at some point to make it get really wide, but it's going to continue to get wider. So that there is no restriction on the domain or range. So my domain is what you can say all real numbers. It's like the double R, or it may list out all real numbers. And then range is going to be basically from that bottom point. So there's nothing, if you'll notice, there is nothing below this line right there. Okay, so nothing, there's no function that's going to, and then there's nothing that we can plug in that's going to make it be below that line. So this is where we have a restriction or a little bit of change here, is that our range, all the values are going to have to be greater than -5. Everything's going to have to be greater than -5. And then then that's it. So all real numbers, it's all going to continue on. It's just that our range is not going to go below that specific line. That's also, you'll note that that is where the vertex is, which is right there. Okay. So finding that vertex is very, very key. Remember the divers and the baseball, it's not going to go above a certain point. With the divers, they're not going to go up above a certain point. So that's what you want to kind of make sure you understand about that, that restriction on the range. So let's look at example 2 here. You'll notice that it is a table. So this one looks a little bit different. I mean, you could plot these points, more than welcome to plot these points, and then look and see what does this quadratic look like. But you'll see some things where you start to see they repeat. So notice that you start to see repeat here and here. And then you see repeat here and here. And so they start repeating, but this point right here never repeats. This is what I would call, this is my vertex. And so my vertex, so it's going to go through that point. And so you'll notice about the rest of the numbers, they don't ever get basically above -4. That sounds kind of silly, but they don't get above -4 because this parabola is going to open down. So if I were to plot these, kind of sketch these, you know, have -5, -8, -4, -5, -3, -4, -2, -5, 0, -8, and then it starts going on, so forth and so on. This should be -1. Sorry about that. So it's going to look something like this. So this is just a rough sketch. So you see that I have a maximum. So it's not only just that my vertex is this is also my maximum. So y is not ever going to get above that. That's why it's called a maximum. And so therefore my range is going to be y is going to be less than equal to, I did not put equal to on the other part. It is going to be equal to, less than equal to -4. And then my domain, again, is going to be my all real numbers. And then the last one, it says it wants you to find the domain and range represented by this quadratic function. And then you're going to find that you'll want to graph that on your graphing calculator and then go back and look and see if that is it a maximum or a minimum, and then base that off of your range there. So after I graph this, you can see that, again, because it's a quadratic function, remember my domain is going to be all real numbers. So that excludes all imaginary numbers. And I know that seems silly, but that's really what they want to make sure that you know, that it's not going to include imaginary numbers, which you'll get into later on in Algebra 2. And then the range, you can see it's going to be a maximum. And so the range is going to be y is going to be less than or equal to +9. So it goes up to 9 and then comes back down. And then that is our quadratic function there. So just remembering x, remember domain for quadratic functions, all real numbers, and then for linear functions, all real numbers. So you don't have any restriction there. And then for range, remember with quadratic functions, you're going to have that point is going to be at your vertex. So that's going to be the key point that you're looking for is your vertex. Is it a maximum or a minimum? Remember, if it's a maximum, of course, there can't be anything above it. So everything would have to be less than. So let's make this little note over here. So if you have a maximum, you're going to use, it's going to be y is going to be less than or equal to. If you have a minimum, y is going to be greater than or equal to. So that's going to be for your range. So identify your vertex. Is it a maximum or a minimum? And then go from there. and then you'll be able to write your range. So it's just that easy. Now, just basically make sure you pay close attention that we're not restricting any kind of domain. And, you know, you should make sure you pay close attention to that. And then I think you got this.